This is Mount Archuno and Mount Anjas Moro, the source of the Brantas River, one of the major rivers of East Java. The Brantas River is 320 kilometers long, and its basin covers an area of 12,000 square kilometers. This river flows to the south and then north to the Madura Straits, near the city of Surabaya. Rivers, the cradles of ancient civilization, are inseparable from human existence. The Brantas River has also had a great influence on the lives of the people living in its basin. The population of this area is about 13 million. 70% of the people are engaged in agriculture. Arable land accounts for 730,000 hectares, or about 60% of the entire basin area. Paddy fields cover 330,000 hectares. The major agricultural products in the basin are rice, sugarcane, cassava, soybeans, and maize. The yearly production of staple crops are milled rice, about 2 million tons, and sugar, about 230,000 tons. This basin, with its plentiful water sources, is one of Indonesia's main granary regions. In recent years, several industries have developed around Surabaya city, located on the lower reaches of the river. This area is growing fast. The Brantas River is an indispensable source of both industrial and municipal water. In fact, the Brantas is called the Mother River of East Java. However, it is faced with a major problem not found with other rivers. This is caused by Mount Kurdistan, a volcano towering over the Brantas River Basin. Records show that Mount Kurdistan has erupted 10 times between 1811 to 1966, or once every 15 years on the average. Each eruption generates about 100 to 300 million cubic meters of volcanic material. Initially, more than 30 million cubic meters of debris flows down into the Brantas River. The riverbed is elevated year by year, rising about 1.5 meters in 15 years, making the bed higher than the surrounding land. Consequently, during the rainy season each year, the river basin suffers heavy flood damage. "600 years ago, during the Mojopahit Kingdom, Mojokerto city was the port facing the Java Sea. The Brantas River has brought down sediment over the last 600 years to form the present Sidoarjo Delta, extending 50 kilometers to the sea. In 1961, the Brantas River Basin Overall Development Plan was drawn up as a part of the National Land Development Program. The aim is to prevent annual flood damage and to utilize the natural river source to create a better life for the people along the river. This was the first attempt in Indonesia to carry out an overall development plan of an entire river system. In the first plan, the outline and significance of the Brantas River Basin Overall Development Plan were as follows. The master plan is composed of 5 categories. The first is flood control, building dams in the upper reaches of the river. The second is flood and erosion control of the large tributaries. The third is erosion control on the slopes around Mount Kurdistan, aimed at preventing the flow of debris. The fourth is to increase flood carrying capacity in the lower reaches. And the fifth is to utilize the water thus regulated to generate approximately 170 megawatts of electric power, to increase rice production by about 210,000 tons through the improvement of the existing irrigation area and development of new areas, and to improve the municipal and industrial water supply to Surabaya city. The various projects in the development plan were appraised. As a result, it was decided that for flood control, irrigation, and power generation, priority would be given to the Karankatis and Lahore Dam projects on the upper reaches of the river, and the Selorcho Dam project on a tributary, the Konto River. In addition, the Porong project, including the new Lengkong Dam in the lower reaches, was selected as the next priority. In the Tulungagung district, the elevation of the Brantas River bed created a vast swamp area of 3,000 hectares throughout the year. The area of 28,000 hectares was inundated for more than 100 days and could not produce even one rice crop during the year. After completion of the first South Tulungagung drainage tunnel in 1961, the swamp area was reduced to 1,550 hectares, and the inundation area to 13,000 hectares. The inundation area was further reduced to 4,120 hectares in 1978 by providing drainage canals. This project contributed to alleviate flooding of the Brantas River. This is the present main office of the Brantas River Basin Overall Development Project in Malang. The organization and systems required for the implementation of the large-scale overall development so far in Indonesia have been established under the Ministry of Public Works. Based on the master plan, feasibility studies and detailed design were carried out. The construction work started in 1962. April 1964. The time has come for the environment of the Brantas River to be subjected to great change through the diversion of the river for the construction of the huge Karankatis multi-purpose dam. The powerful flow of 40 cubic meters per second is completely blocked by the large volume of rock and concrete blocks dumped into the river. Heavy equipment offloaded at the port of Surabaya is transported to project sites for the construction works. embankment work of the Karan Katis Dam gets underway. Now, the work reaches its peak. The heavy equipment looks small as compared to the huge dam. Inspections of dam embankment materials are conducted in this laboratory for quality control. The rock-fill type Karan Katis Dam is 100 meters high. This huge structure has a volume of 6.2 million cubic meters and a total storage capacity of 343 million cubic meters. Thanks to this dam, a flood of 920 cubic meters per second, which is a once in 100 years probability, would be reduced to 320 cubic meters per second at Kediri City in the Middle Reaches. A family of long-tailed monkeys seen in the mountain village of Selorcho. The Selorcho multi-purpose dam will be built here on the Konto River. Construction of the diversion tunnel had commenced in April 1965, and now the dam construction work is in full swing. Due to the large amount of volcanic materials flowing down from Mount Kulut, there are heavy flood damage every year along the river up to the confluence with the main river at Kertotsono. Flood damage is reduced in the lower reaches of the Konto River by construction of the Selorcho Dam and Savo dams. Construction of the Selorcho Dam was completed in 1972. The huge Karan Katis Dam now takes shape. The environment surrounding the dam has changed greatly. Relocation of the railway to be submerged by the Karan Katis Dam is completed. Major changes are taking place not only in the natural environment of the upper reaches of the Brantas River, but also in the life of the people living in the area. Those living in the villages to be submerged by the Selarejo and Karan Katis reservoirs move to a new settlement. Construction work of the Karan Katis power station begins. The transmission line extending toward the Warutu substation in the suburbs of Surabaya city. The levees in the middle and lower reaches of the Brantas River are dangerous during flood time due to volcanic sediment. Dredging of sediment and improvement of levees in the lower reaches is urgently needed. The Kali River Improvement Project is implemented for this purpose. The riverbed is lowered by dredging. Levees are protected by the pile dike growing method. Damaged levees are repaired. And low levees are heightened. The Lengkong Dam, constructed more than 100 years ago to supply agricultural, municipal, industrial, and flushing water, has already lost its function. The new Lengkong Dam, with an electrically operated gate, replaces the old dam. The new Lengkong Dam is constructed just downstream from the old dam. From this point on, the lower reaches of the Brantas River becomes the Poron River. In 1973, the projects in the upper reaches were completed one after another. The Brantas River Basin has entered a new era. July, the Selorejo Power Station is completed. Power generation capacity is also increased at the existing Mendalan and Siman power stations by increasing the water supply from the reservoir of the Selorejo Dam. September, the Karan Katis Dam is completed. The opening ceremony was carried out in the presence of President Suharto. The generators at the Karan Katis power station were immediately put into commercial operation. The Karan Katis area now becomes a recreation center. The Lahore multipurpose dam is located 1,500 meters away from the Karan Katis dam. These two dams will function in combined operation. This is the construction site of the connection tunnel. In the dry season, the flow is increased by 25 cubic meters per second by joint regulation of both dams. Also, this will lead to a great increase in rice production, municipal water supply, and so on. The installation of 3 units of 35 megawatt generators will make a major contribution to the electric power supply in East Java. On completion of the Lahore Dam project, the Karan Katis power station will become a peak power station with 3 generators. November 1973, the new Lengkong Dam is also completed. Now, the gate operates smoothly. In 1973, the overall development plan was reviewed, and a priority list for all further projects was drawn up. The food production plan was conceived as the first priority to comply with the national policy in Palita 3 for self-sufficiency. Based on this, several irrigation projects were recommended for implementation. The Walingi Dam and Lodoyo Tulungagung irrigation, rehabilitation of the Waru Jayeng and Turitungorono irrigation, the Benin Dam and Widas irrigation, the Gunung Sari Dam and irrigation, and rehabilitation of the Brantas Delta irrigation. Feasibility studies and design work for each project were immediately commenced based on this plan. The construction site of the Walingi Multi-Purpose Dam, located 35 kilometers downstream from the Karan Katis Dam. Special treatment of the foundations are carried out. Water is pumped up by deep wells during excavation of the sand and gravel riverbed. Chemical grouting is used for the limestone foundation. Even with the same type of dam, the most suitable method is selected to meet geological conditions at each site. The Walingi Dam is a combined concrete and fill type. Dam embankment work continues. In 1977, the Lahore Dam, Walingi Dam, and Poron River improvement works were completed. The Karan Katis and Lahore dams create artificial lakes lying side by side. The names of the Karan Katis Dam and Power Station were changed to the Sutami Dam and Power Station in commemoration of the late Dr. Sutami, the Minister of Public Works who contributed greatly to the development of the project by the decree of President Suharto. This is the Walingi Dam and Power Station. The irrigation water for the Lodoyo and Tulungagung area is taken from the Walingi Dam. The Walingi Reservoir serves as an afterbay for peak power generation at the Sutami Power Station. This chart shows the function of the afterbay. It regulates the water during peak power generation and controls the discharge on the downstream side. This is the proposed site of the Lodoyo Dam, 7 kilometers downstream from the Walingi Dam. The Lodoyo Dam will also serve as an afterbay for the Walingi Power Station. A second generator will be installed at Walingi and will serve together with the Sutami Power Station to meet peak power demand. The Lodoyo Afterbay Dam was completed in 1980. Through the completion of this dam, the Walingi Power Station was also commissioned as a peak power station with an output of 54 megawatts. The Brantas River is branched to the Surabaya River at Mojokerto. The Surabaya River Improvement Project is being implemented. This project involves various works for flood control, water utilization, and flushing, improvement of the Marmoyo River, Surabaya River, and Mas River, reconstruction of the Gunung Sari Dam, and so on. In the case of the Mas River, which flows through the city of Surabaya, urban drainage improvement works are involved. This is the construction site of the Gunung Sari Dam. The Gunung Sari Dam, built about 70 years ago, is reconstructed with new functions. The new Gunung Sari Dam is now in operation to provide water for Surabaya city and the irrigation of 2,800 hectares of land. Meanwhile, maintenance work of the Poron River is carried out continuously. The Brantas Middle Reaches River Improvement Project, also in progress. River improvement is based on long-term planning, and work is carried out in successive stages. In the reviewed plan of 1973, the effect of the eruption of Mount Kurdistan and its countermeasures were studied. If volcanic material produced by eruptions is retained on the slopes of Mount Kurdistan, the silting problem of the Brantas River could be solved. In the tributaries of the Badak and Putih rivers, Sabo dams are built for this purpose. Overall development of the Brantas River Basin continues to meet further demands. Construction work starts on the 4.5 megawatt Lodoyo Power Station, which will utilize the low head of the dam. The generator installed here is the first large tubular type in Indonesia. In the Tulungagung district, a new supplementary drainage project was drawn up in addition to the existing drainage tunnel to eliminate the remaining swamp area. Excavation of the 24-kilometer-long main drainage canal. The waters drain through this canal to the South Tulungagung Tunnel. In this way, the swampy area and inundation will be eliminated. A 7.5-meter diameter tunnel is constructed alongside the first tunnel. Completion of the drainage tunnel and canal in the near future will bring about great changes in the Tulungagung area. The bridges on the main canal are completed one after another. The Widas River flows into the Brantas River at its middle reaches. The Benin Dam is designed for flood control, water supply to the Widas irrigation area, and power generation. After completion, the dam was inaugurated by President Suharto in 1982. Construction of a micro-power station is underway. This station is provided for the maximum utilization of water resources. The Brantas project also aims to utilize even the smallest potential for developing hydropower. This is the Glotic intake and its canals for the Widas irrigation area. Here we see the proposed site of the Sunguru Dam, 14 kilometers upstream from the Sutami Dam. Construction work commences on the excavation of the diversion channel and the spillway. In July 1983, the river is diverted. This is a 29-megawatt hydropower project. The storage capacity of 21.5 million cubic meters will also prevent sand flowing into the Sutami Dam. The financial sources of the projects are these international and domestic funds. The total finance came to about $500 million as of fiscal year 1984 by the actual amounts being dispersed. Finance from overseas totaled about $250 million, with about 80% coming from the Overseas Economic Cooperation Fund and others of Japan, and nearly 20% from the Asian Development Bank. Thanks to the financial aid and technical assistance from various international organizations, the overall development is making steady progress. The implementation of the Brantas River project has opened up a new era in East Java and also increased the technological capabilities of the project staff. High technology has been employed in all fields of the projects: civil, mechanical, and electrical. Transfer of technology was made by on-the-job training of the Brantas project staff in design, supervision, and construction by the foreign consultants and guidance engineers. Project works were carried out by the Brantas staff by adopting this technology. This newly acquired innovative technology was also applied to successive projects. The great advances achieved by the project staff in terms of planning, construction, and supervision were employed in the construction of the Bening Micropower Station and the Batujai Dam and Irrigation Project on Lombok Island. All operations, from planning to completion, were carried out entirely by the Brantas project staff. These will serve as a model for regional power development. The technology for civil and electromechanical engineering acquired through the overall development project of the Brantas River is gradually spreading throughout Indonesia. From the viewpoint of enhancing the level of industry and culture of the nation, this acquisition of technology is of immeasurable significance. The success of the Brantas project is due to the development of manpower resources. As a result of transfer of technology, the government decided in April 1980 to divide the Brantas Project Office into 3 agencies: the general contractor, Brantas Abipraya, the consultant, Indra Karya, and the Brantas Executive Body. After 10 years from the first review of the overall plan in 1973, a second review is carried out. Studies are made to achieve the optimum plans for land and water conservation, flood control, debris control, and water utilization of the Brantas River, and for improvement of the living environment. These projects are given priority in the second review. Among these projects, preparatory works have already started for the construction of the Wonorejo Dam and Lesti 3 Dam. Preservation of the social and natural environment is a prerequisite in the implementation of the project. Conservation of land at the watershed is vitally important to prevent scouring and to conserve water. The project staff are engaged in these problems, preventing uncontrolled deforestation by implementing agroforestry, providing bench terraces, and advocating tree planting among the local people. Another important problem in the upper reaches, besides siltation due to forest clearance, is the volcanic materials produced by the eruptions of Mount Bromo and Mount Semeru in 1975 and 1981. Resultant debris flows into the Sutami Reservoir year by year. To solve this problem, many Sabo dams must be constructed as soon as possible upstream from the Sutami Dam, in addition to the Sunguru Dam shown here. One of the proposed sites is the Lesti 3 Dam. Feasibility studies are carried out. An old dam on the Ampron River collapsed in 1967 due to a big flood which carried down much timber and threatened the Sutami Dam, then under construction. It is thus proposed to build a dam in the upstream area to prevent timber from being washed down. The Tulungagun project will be implemented in 3 phases: the present drainage, the coming Wonorejo Dam irrigation and power facilities, and the future Trenggalek Dam and irrigation project. In the second phase, the Wonorejo Dam and Segawe Dam are planned. The Song River will be diverted to the Wonorejo Dam through a connection tunnel. The Wonorejo Dam on the Godang River is a multi-purpose dam most urgently required for implementation. This dam, 97 meters high and with an embankment volume of 6.4 million cubic meters, is a fill-type dam. Construction work of the Wonorejo Dam got underway in 1983. Here we see the proposed site of the Segawe Dam on the Song River. This is the proposed site of the Tugu Dam in the 3rd phase. At the construction site of the Wonorejo Dam, the diversion tunnel is now penetrated. The Wonorejo Dam is also planned to supply about 6 cubic meters of water per second to the downstream irrigation area and to the growing city of Surabaya during the dry season. As the water demand for Surabaya city is increasing year by year, water supplied by the Brantas River is not sufficient. In the drought year of 1982, there was no rainfall for almost 10 months, and the discharge of the Brantas River decreased greatly. Surabaya city and its vicinity suffered from water shortages, and the rivers in the city were heavily contaminated due to the lack of flushing water. In order to supply sufficient water to Surabaya city and its surroundings, it is necessary to develop both the Brantas River and its tributaries. At the outlet of the South Tulungagung drainage tunnel, a 30-megawatt power station utilizing a head of 70 meters is planned. July 1984, the inauguration ceremony for the Lodoyo Power Station was held. In attendance were Dr. Subroto, Minister of Mines and Energy, Dr. Suyono, Minister of Public Works, and other high-ranking government officials. The Lodoyo Power Station is now functioning as a part of the Brantas power system. Potential hydropower available for development is restudied. As a result, it is still possible to develop about 30 sites having a 400-megawatt power capacity. This chart shows the network of the Brantas power system as of 1984. In the Widas River Basin, in addition to the Bening Dam, the Kedung Wadak Dam and other dams are planned. A feasibility study is being carried out for flood control, river improvement, irrigation, and power development. A telemetering system is required for forecasting floods, issuing warnings, and controlling low flow along the river.
Ini sekarang terdiri jam 11.29, jam 21.27, jam 3.1.
Rainfall and river water level data along the river will be automatically sent to the center in Malan by telemeter, and warning of floods will be given to projects and downstream areas through a special telephone system. The present communication system with a central station at the Brantas office. In developing a river basin, it is desirable that one central office undertake integrated planning and control of each project. Such a system has been adopted for the Brantas project. Through the efforts of the Brantas staff and other agencies concerned, the overall development of the Brantas River Basin is moving forward to successful completion. The Brantas River, and indeed the whole of East Java, are making positive progress toward the 21st century. Water flows along an irrigation canal. Rice production in the Brantas River Basin has increased greatly. Today, the Brantas River Basin is greatly contributing to Indonesia's annual production of rice. The total generating capacity of projects in the Brantas River Basin reached 200 megawatts. This is 26% of the total of East Java. Since completion of the Sutami Dam in 1972, flood damage downstream has almost been eliminated. Water demand in the basin is growing year by year, but cannot be met merely by developing reservoirs. To meet demand, it is essential to establish a total basin water management system controlled by one body. The Brantas project will play an important role in this system for the management of water resources and as an engineering center for analysis, study, and forecasting. The success of the Brantas River Basin Overall Development Project will serve as a foundation for the future development of East Java and will ensure a bright future for all of Indonesia.